Hello, everybody. Hey, let's talk about midpoints, not midpoints, distance, and circles. Oh my! This is us going over the homework, the worksheet that you had. And so yeah, let's take a look at it. These first four problems are just your most basic. You had to find the distance and the midpoint between them. And so I'm going to go distance first on each of these and say, okay, so the distance is always equal to. And you remember, order doesn't matter except for the fact that we got to keep the x's with the x's and the y's with the y's. That's what it always matters. Okay, so every time your formula should look like this. You're keeping the x's with the x's, the y's with the y's. You're squaring each part of those, you're adding it up, and you're taking the square root of the whole thing. That's what it should look like every time. Okay, so therefore the distance is equal to the square root of, I'm going to go -6 minus 2, square that, plus 8 minus 3, square that. And at this point, you really can do a lot of the math in your head. -6 minus 2 is -8, so I've got -8, I'm going to square that, plus 8 minus 3 is 5. Okay, -8 squared is positive 64. And 5 squared is 25. Add that up, and I get the square root of 89. All right, and then to find the midpoint between these two, remember, midpoint, we always just think average. So we always have to add up the two x's and divide by 2. We add up the two y's, and we divide by 2. And so again, order doesn't matter as long as you keep the x's with the x's and the y's with the y's. So that's all that matters. So in this case, the midpoint is going to be -6 plus 2 over 2, and 8 plus 3 over 2. And so therefore the midpoint is -6 plus 2 is -4 over 2. 8 plus 3 is 11 over 2. And so the midpoint is -2, 5.5. All right, that's the midpoint between A and B. Now we got C and D, number 2. Okay, so I'll try to make this one a little bit neater and keep everything kind of tight. The distance is equal to, so we have, I'm going to go 7 minus 5 just because it's easier, plus, we'll say what, -9 minus 4 squared. Okay, so 7 minus 5 is 2. We got 2 squared, plus -9 minus 4 is going to be -13 squared. 2 squared is 4. 13 squared is 169. And then we add those up and we get square root of 173. Midpoint. For the midpoint of those, we keep the x's with the x's. 5 plus 7 divided by 2. Keep the y's with the y's. 9 plus 4 divided by 2. And so therefore the midpoint is 5 plus 7 is 12 over 2. -9 plus 4 is -5 over 2. And so therefore the midpoint is 6 and then -2.5 or -2.5. For the distance and midpoint between E and F, the distance is going to be equal to the square root of, I'll say -7 minus 1 squared plus 11 minus 3 squared. -7 minus 1 is -8. And I'm going to square that. 11 minus 3 is 8. And I'm going to square that too. And now this is where if you misuse a calculator and you type in -8 squared, it'll tell you the answer is -64, unless you use parentheses. And so this should be 64 plus 64, which gives me a grand total of the square root of 128. The midpoint of these two is going to be -7. That's an ugly 7. -7 plus 1 divided by 2 and 3 plus 11 divided by 2. So therefore the midpoint is -7 plus 1 is going to be -6 over 2. 3 plus 11 is going to be 14 over 2. And so therefore when I simplify that, I get -3, 7. Pretty simple. All right. And let's see here. Last of that type of problem, we got to find the distance and the midpoint between G and H. The distance is going to be equal to the square root of 8 minus 2 squared plus -10 minus 4 squared. Okay, so 8 minus 2 is 6. Squared -10 minus 4 is -14. We're going to square that. 6 squared is 36. 14 squared is 196. And so we got 196. And then when we add those up, we get, 232. Square root of 232. And the midpoint, add up the x's, 8 plus 2, divided by 2, add up the y's, 4 plus a -10, 4 plus a -10, divided by 2. So therefore the midpoint is 8 over 2 is 10 over 2, 4 plus -10 is -6 over 2. Midpoint is 5, -3. Okay. So those are the most basic. You got to be able to do that kind of stuff. That should be just, really, really simple. The biggest keys to remember is that you're always subtracting in distance, in those little parenthesis groups, and you're always adding. You got to square them. You're taking the square root of the whole thing. With midpoint, you're always adding. Now, sometimes you're adding a negative, which is similar to subtracting, but you're always adding. All right, let's look at the next one. Number 1 says, okay, I want to find the point that is 1/4 from A to B. And we talked about this. We said, well, if you're going from A to B, that halfway in between them would be M. So we got A, and the M is being the midpoint. And then if we went halfway between A and M, this right here would be 1/4 of the way, 1/4 of the way from A to B. So really what we do is we find the midpoint between A and B, which is M, and then we just find the midpoint between A and M. And so it's just a midpoint after a midpoint problem. That's all it is. And so we're going to start and do the first midpoint, the midpoint between A and B. And so we get that midpoint is going to be what? Negative 10 plus 6 over 2, and then 2 plus 10 over 2. Okay, and that simplifies down to, let's see, negative 10 plus 6 is going to be negative 4 over 2, and 2 plus 10 is going to be 12 over 2. And so that's going to give me a midpoint of negative 2, 6. So that's my midpoint between A and B. But now I got to find the midpoint between that and A. And so to give myself just a little more room, I'm going to get rid of this stuff right here and say, okay, so now I got an A, which is at this negative 10, 2. And I've got this midpoint, which is at negative 2, 6. And I got to find the midpoint between those two. Okay, so I don't know what I want to call this, but I'm going to call it like midpoint number 2. I'll put a little subnotation on it. And so I got to go negative 10 plus a negative 2 over 2, and then 2 plus 6 over 2. And so therefore this midpoint, negative 10 plus a negative 2 is going to be negative 12 over 2. 2 plus 6 is 8 over 2. Negative 12 divided by 2 is going to be negative 6, and 8 divided by 2 is 4. So there you go, okay? Negative 6, 4 is the point right here. This is the point that is 1/4 of the way from A to B. I didn't really allow myself enough room when doing these problems, so they've gotten a little bit messy and sloppy, and I'm sorry about that. But hopefully you're able to follow along with all that meant. Okay, we said first we had to find the midpoint between A and B, which was let's see, this guy right here. And then we had to find the midpoint between that one and A, and that was this guy right here. So this is the one that is 1/4 of the way. All right. Next, number 2 says, hey, we want to prove that these points are collinear by showing that the distance between A and B and the distance between B and C add up to be the distance between A and C. And I think I got at least a brief explanation in every class kind of talking about this. So basically, it's this situation right here. Kind of imagine this. I could say, here's the point A, and here's the point B, and here's point C, and here's point A, and here's point B, and here's point C. And let's say that the distance between A and B was, we'll say 5, and the distance between B and C is 3. Well, then that would be the same here. Now, then the distance between A and C would clearly be 8, 5 plus 3. But see, in this situation, the second situation, C would be a little bit closer because it's not all on a line. It's not collinear. And so C would not be 8 units away, but in fact, it would be a little bit less than 8. Okay? And so that would show that those points can't be collinear. If they're collinear, which means all 3 points are on a line, collinear. Co meaning with or together, linear meaning line, so together on a line. The 3 points are collinear if the distance between the first two plus the distance between the second two adds up to be the distance between the first and the last. Okay? They are not collinear if the distance between the first two and the distance between the second two ends up being different, or in fact more than that distance from the first to last. And so this is a little bit of a proof showing that they are collinear. Okay, so you got to find the distance between the first two and the distance between the second two and the distance between the first and last. So that's what we're going to do now. Now that I've got all this drawing and scribble everywhere, let me shift this stuff down. Okay. All right. So we're going to first start with the distance between A and B. And that's going to be, what, negative 5 minus 1 squared plus 9 minus 0. That's easy, squared. Okay, so this one gives me negative 5 minus 1 is negative 6. And I've got to square that. 9 minus 0 is just 9. I'm going to square that. So I get 6 squared is 36. 36 plus 81. And that is, what, 117? I think. Okay. I'm pretty sure. Okay, and then let's go to the distance between the second two. Distance between B and C. So you go square root of, let's see here, 9 minus 1 squared plus negative 12 minus 0 squared. And let's see what we get. Square root of 9 minus 1 is 8. Negative 12 minus 0 is negative 12. 8 squared is 64. 12 squared is 144. Can add those two up, and so the distance is equal to the square root of 64. What is that? 208. Okay, pretty ugly numbers. And then lastly, the distance between A and C. And I'm running out of room here. Let's see. We're going to make it work. Okay. So distance between A and C. So you got negative 5. Here's what we'll do. We'll zoom in. Make this a little bit easier. Okay. All right. So we're going to say negative 5 minus 9 squared. And then what are the other two numbers? 9 minus a negative 12. So plus negative 12 minus 9 squared. I'm going to double check those numbers. 9 and negative 12. Yeah, okay. So what does that equal? Well, that equals negative 5 minus 9 more puts me at negative 14. And I've got to square that. Plus negative 12 minus 9 is negative 21. And I have to square that. So 14 squared is 196. And 21 squared is 441. And if I add those up, I get, let's see, 196 and 441. Blech, what is that? 637, I think. Square root of 637. Boy, that makes you want to throw up a little bit, doesn't it? Oops, 637. Okay, so now the question is, does this plus this add up to be this? And as we look at it, we go, I don't think so, because that just looks so freaking ugly. There's nothing about that that really makes a lot of sense. And because I left myself so little room, I've got very little room to try to explain this. So let's shift these down a little bit more, shift these down a little more. Okay, yeah, that'll go a little further. All right. So here's what we got to do. We actually got to try to simplify this radical. Now this would got to be an uglier radical than I meant for it to be. But the square root of 17, I know that a 9 goes into it. And if you didn't know this, but if you add up the digits in a number and it equals 9 or a multiple of 9, then the number itself is divisible by 9. So 1 plus 1 plus 7 is 9. So I know that 9 goes into there. So I know 9 times something gives me 117. And it's actually, the answer is 9 times 13. And see, the reason why I do that is because I know the square root of 9. And so that means this is the same thing as 3 times the square root of 13. All right? Now, let's look at this next one. What numbers go into 208? Now, that's a little bit of a tough one. Golly. I know the answer, but man, it's just not... 208 is the same thing as 16 times 13. And the only reason I know that is because I know that 64 is 4 times 16, and I know that 144 is 9 times 16. So here's 4 16s, and here's 9 16s. So therefore, 208 must be 13 16s. So the distance is equal to 13 times 16. I know the square root of 16 is 4. So therefore, this distance is actually 4 times the square root of 13. And the question is, okay, 3 square root of 13s plus 4 square root of 13s should in fact equal 7 square root of 13s. If this is right, then that's what this would have to be. And so really, now that I know that, I can just check it, because this is a pretty big number. And so I get nervous about, man, what goes into that? But the question is, I think 13 does. And so let's divide 637 by 13. Look at this, dude. Old-fashioned long division. Man, do we even know how to do that kind of stuff anymore? And how many times does 13 go into 63? Well, it goes in 4 times. 4 times 13 is what, 52? And that leaves us with 117 left over. And we already saw 117, right? We know that's 9 times 13. So therefore, we know this goes in 9 more. And there we go. Check it out, 49. So we know that the square root of 637 simplifies down to 49 times 13. And we know the square root of 49 is 7. So it is 7 times 13. Check it out. Math is true. All right, so I hope you were able to follow that one, but I know it was a little bit complicated and crazy. We just found the distance between the first 2 points, distance between the second 2 points, and tried to make sure it was equal to the distance of the first to the last point. Yeah, sorry. I know that one got a little wild because those were hard to simplify. Okay, this next one, we're supposed to kind of prove the converse of the Pythagorean theorem, basically saying, hey, does the distance between, it's saying, if a squared plus b squared equals c squared, then it must be a right triangle. Because we know if it is a right triangle, that this is true. And so what we're doing is we're finding, notice these are lowercase, and right here, these are uppercase, because the uppercase are corners. Okay, those are corners of the triangle. A, B, C. And the lowercase are always opposite of their corner. The lowercase. And okay, there we go, like that. So A would technically be the distance between B and C, and B would technically be the distance between C and C would technically be the distance between A and B. And so we're just, going, okay, we got to find distances again. And this was a lot of homework dealing with distance. So what do we got? Distance for between A and B. So we'll go the distance between A and B, which is actually going to be C, is going to be square root of -3 minus 1 squared plus 7 minus 1 squared. So the distance is equal to, that's going to be -4 squared, which is 16. That's going to be 6 squared, which is 36. Add those two up and I get D is equal to square root of 52. Okay, let's go from B to C. And that should be A. The distance is equal to the square root of B to C. So we'll go 7 minus 1 squared plus 5 minus 1 squared. Distance is equal to 6 squared plus 4 squared. 6 squared is 36. 4 squared is 16. Add those up and we get square root of 52. So once again, we got square root of 52. And now let's check the other one. Now maybe, I'll be honest, these points might be labeled wrong. And so maybe the C side of the triangle might not actually correspond to the opposite of this C. And I'm sorry if that's the case. I hate it when things like that, when I've written it out wrong or something. But so let's find the last distance. And the distance would be from A to C. And so we'd say the distance is equal to square root of 7 minus a -3 squared plus, 7 minus 5 squared. So 7 minus a -3 is 10. So we have 10 squared. 7 minus 5 is 2 squared. So that's going to give me 100 plus 4, which is 104. Now, how nice is this? Because we plug these into this formula, a squared plus b squared equals c squared, we get to square each one of these, which drops the radical. So where the question is, does square root of 52 squared plus the square root of 52 squared equal the square root of 104 squared? And of course, because those cancel out, and cancel out. So it's just, does 52 plus 52 equal 104? The answer is yes. So those must be the vertices or the corners of a right triangle. Yay. Okay, we're getting there. We're almost there, guys. Sorry this is taking so long. If you've watched the video to this point, hopefully you've put it on like quadruple speed or something. You haven't had to listen to me talk this whole time. All right, but let's look at this one. Sounds like I have people getting ready to walk through my door. Okay, so here we go. X-axis. Every point on the x-axis, when you think about the coordinate plane, every point on the x-axis, whether it be here or here or here, all those points, that could be like 2, 0. This right here could be 1, 0. This right here could be 3, 0. Notice what's in common is the y value is always 0. Every point on the x-axis has a 0 for a y value. And so we kind of know that going into it. Now the question was, what's a point on the x-axis that's equidistant between these 2 points? So I know that the point on the x-axis is going to have an x-coordinate and the y-coordinate is going to be 0. So what I do is I find the distance from here to here, and then I find the distance from here to here. And because I want them to be equidistant, I set those two distances equal to each other. All right. There's lots of rustling going on and things like that in my house because someone just went to Dollar General. Woo! All right. Okay. So let's do this distance. So the first distance is going to be 6 minus that x value squared plus -6 minus 0, that y value. We know the y value is going to be 0. And then we set that equal to the other distance. We want them to be equidistant. So I go -3 minus x squared plus 6 minus 0 squared. Okay, now let's take a look at this. I do not get to say I can get rid of these those exponents because I have this radical. Can't do that. Can't do that on this side either. But what you can do is you can square both sides. So if I square both sides of that equation, this cancels out with this, and I am then left with 6 minus x squared plus -6 minus 0 squared equals -3 minus x squared plus 6 minus 0 squared. Okay, we know that this is just going to be 6 squared and this is going to be 6 squared, so that's going to be 36. And then we can FOIL this one and FOIL this one. So I might move a little bit quick here, but so 6 times 6 is 36. This times this is -6x, double it, -12x plus x squared. FOIL the next one, you get plus 30, or now we have plus 36 equals, FOIL this one, we get 9 plus 6x plus x squared plus 36. Now look at just everything that cancels out. There's a 36 on both sides, that's gone. There's an x squared on both sides, that's gone. And so now it just becomes this first order linear equation. Move all the x's to one side, move the numbers to the other side. So we're going to subtract 9 from both sides and add 12x to both sides. And 36 minus 9 is 27. These are gone. Equals, those are gone. 6x plus 12x is 18x. So therefore, x is equal to 27/18, which is the same thing as 3/2, which is the same thing as 1.5. So the answer is, the coordinates of the point are 1.5, 0. That is the point that is equidistant from those other 2 points. Whew. Okay, hey, let's do these circle problems because circles are easy. We used to think circles are hard, but no, circles are easy. Okay, let me shift some of this stuff out of the way. Just so we've got more room. What we need to think about is the general equation for each circle, whether it's centered at the origin or centered at the centered at some given point. And so we need to kind of think through that a little bit. So when it's centered at the origin, it's just x squared plus y squared equals radius squared. When it's centered at some other point, it's x minus h squared plus y minus k squared equals the radius squared. So this says it's centered here, so we need to plug in those points for there and there. And it passes through this point, so we need to plug that into the equation or substitute it in. So we get x minus 2 squared plus y minus 5 squared equals, now we don't know what the radius is. So, but what we can do is we can plug this point in for our x and y, and then we'll figure out the radius. So that would give me 7 minus 2 squared plus -2 minus 5 squared equals radius squared. 7 minus 2 is 5. Square that, we get 25. -2 minus 5 is -7. Square that, we get 49. So therefore, my radius squared is going to be equal to 74. And then you rewrite the equation. X minus 2 squared plus y minus 5 squared equals, not r squared, equals 74. All right. Next one, virtually the same thing, except it's got this little shortcut. And that is the fact that it's tangent to the x-axis. Now, when we did this in class, I said, hey, go ahead and draw this. If we think about, here's the x-axis, but it's at -5. Let's go back, say that's -5. On all the way up at 9, we'll say that's 9. Okay, so the center's right here, but it's tangent to the x-axis, which means it just touches the x-axis in one point, which means this is the radius, and that is 9. So this one is just a riddle that you can just easily figure out and go, it must be x plus 5 squared plus y minus 9 squared equals, the radius is 9. We square that. We get 81. All right, lastly, let's do some factoring. We're good at these. You guys are superstars at these. So we have here, first thing we do is reorder it. X squared minus 6x plus blank plus y squared plus 10y plus blank equals -9. Half of -6 is -3. Square it, we get 9. So add 9 to this side. Half of 10 is 5. Square it, you get 25. Add 25 to this side. So we go, this is x minus 3 squared plus y plus 5 squared equals 25. So where's the center? The center is at 3, -5, and the radius is 5. All right. This next one, rewrite it. X squared plus 12x plus blank plus y squared minus 16y plus blank equals, I'm going to go ahead and subtract the 7 from both sides and get 3. Half of 12 is 6 squared, I get 36. I'm going to add that over here. Half of 16 is 8 squared, I get 64. Yeah, add that right here. Okay. And so therefore I get x plus 6 squared plus y minus 8 squared equals 3 and 36 is 39 plus 64 more is 103. Okay, so the center is at -6, 8, and the radius is square root of 103. Did I do that on the last one? Yeah, I wrote everything. Okay. Second to last one, almost done, guys. Rewrite it. X squared plus 14x plus blank plus y squared minus 8y plus blank equals 29. Half of 14 is 7 squared, you get 49, so add 49 to this side. Half of -8 is -4 squared, you get 16, add 16 to this side. So this is going to factor down to x plus 7 squared plus y minus 4 squared equals 29, and 49 gives me 78. 78 plus 6 more is what, 94? What an ugly number. I think that's right. We'll pretend it's right, whether it's or not. And so therefore the center is at -7, 4, and the radius is square root of 94. Last problem. Look, something's missing. There's no x term. So that means x squared is all by itself. And you got y squared minus 20y plus blank equals -7. Half of -20 is -10 squared. You get 100. Add 100 to this side. And we just get x squared plus y minus 10 squared equals 93. So therefore the center is at 0, 10, and the radius is square root of 93. And finally, we are done. I hope this made sense.